In several science courses, we have virtual labs. This is Physics A, the first virtual lab. I'm going to walk you through kind of how to do this, okay? So let's go ahead and get started. Each lab has your online instructor go through the ideas of what the lab is for. There's a little bit of a warm-up, there's a little bit of instruction. They'll get you started with that, and then eventually they get to the point to where they talk about the online tool, which is a Gizmo, where the lab is actually done. So the instructor will actually kind of show you a little bit about the Gizmo, but the actual instructions are in the document that you can download. So this video is going to show you a little bit more about walking you through and entering data into that document. So you can click on the student guide and the document opens and it gives you the pre-lab information. It might seem like a lot, but if you commit not to skip this and actually read through the directions, you're going to understand the content in the course a little bit better. This is what we have to learn hands-on, and hands-on is an important piece of science. But you see we have the lab procedure and so on and so forth, but the main thing is when we get to the Gizmo, the steps, and the data, and analyzing the data as well. The online instructor actually goes through how to enter data into the data table. But one thing that they don't do is they don't actually show data being entered into the data table. So I'm going to be doing that. So on this screen you click here to actually open up the Gizmo, which is the simulation in order to do the lab. And then you're going to be opening the document in order to actually see the data. Well, where to put the data in. So this gives you the instructions. So here it kind of shows you what the Gizmo looks like, gives you some steps, and so here we have step 2. Step 2, 3, and 4 are actually pretty much identical processes with different fan speeds. So first we're going to start off with low fan speed and no friction according to the directions. It says open the data tab and select the button speed and line graph, and then click the play button and let the cart run past the finish line. So data, click speed and line graph, click the play button and let the cart run past the finish line. Now once the cart crosses the finish line, then we record the data from the speed data table into your lab guide in table A in the low fan speed column. So we're going to find table A is right there, and we're going to look at the low speed column, and we're going to just enter in the numbers in the data table here to the left. So I'm going to go clear up to 0. I'm going to go back to the data table, and we're going to enter in those data points. So starting with 0, and then it's 18, and so on and so forth. Here I'm going to speed up this data entry here. So once we get all that in, it looks like there are 7 data points that we get in there that we just copy down, and then take a look at the rest of the directions. The next part says to record the total distance to the finish line and the total elapsed time in table B, and then use that to calculate the average velocity of the cart. So here's the total distance is 500, and the total elapsed time is 7.4 seconds. So we go down to table B, we find where that goes. Now this is for the low fan speed, so we enter in the total distance is 500 and the elapsed time is 7.4, so that goes up 1 right there. So part E here under step 2 says to use the data table or data in table B to calculate the average velocity of the cart. Average velocity calculated by dividing the total distance or displacement delta x by elapsed time. And here's where we pull out our calculator. So we take a look at, we've got 500 divided by 7.4, and that gives us 67.6 meters per second. Next we're going to take a look at how to get our acceleration, and that is up in F in our directions. It says look at the speed versus time graph generated at Gizmo, determine the acceleration of the cart. Remember, the slope of the line gives you the acceleration of the cart, and then record your answers in table B. So here is the slope of that line. We take a look over here at, say, 7 seconds. It is about 100 and I'm going to say 28. About 128. So then we would take 128 divided by 7 in order to get that acceleration. So I'm going to go back into the document and scroll down to the data table, and I'm going to take 128 divided by 7, which is about 18.3 centimeters per second squared. Then we're going to go back up in the directions in the document and see what's next. So here we are, step 2, G, says select the position button to view the plot of position versus time. Record a description of the graph in table C. And so we go ahead and select position so we can take a look at the graph. We see how that's curved. It looks like a parabola, and it goes all the way over to 7 seconds. Okay, so then we go over into the document and we scroll down, and then we describe what we saw there. Here we are in table C for low fan speed, and we say something like the position versus time graph is curved. It looks parabolic. So that's just the description is what we need. So we're going to do that for each of those eventually. So let's go ahead and see what else we have next. It looks like we're done with that trial, so we're going to go on to step 3. It says basically to run the simulation again on medium fan speed, so we're going to reset things by going speed and go back to the experiment, go to medium speed, and then do everything again. So I'm just going to kind of speed up what I've done here, so then you can kind of see what the filled out data tables look like at the end. Feel free to pause it if you wanted to take a look at what the data is as you're doing your lab. You can use this as a reference. But basically, we're doing the same thing as we did before with different numbers, and then we're going to take a look at how those numbers fit with our hypothesis. So here are the numbers. And notice also here, when we go to the position time graph, it is curved and parabolic, but it's steeper. It's like 5 seconds instead of 7. So when the fan speed is faster, when acceleration is higher, then the position versus time graph is curved again. It looks parabolic, but this time it looks steeper still. Next, we're going to scroll up to the last part of the lab, which uses that last data table. This is step 5, run the simulation to achieve a constant velocity. So you open up the data and select the speed button, and then you take it back into the low speed, and then you go ahead and reset it, except we want to try and get it at the sweet spot of 4 seconds, and this is going to take a few times. But once I finally get it there, now we get it at 4 seconds. It took a lot, but it says in part D, open the experiment tab and turn the fan speed off. Then return to the data tab and click on the play button to resume the cart's run. So we turn the fan speed off, and then we're going to go ahead and run the cart again. And then we're going to wait until after it crosses the finish line. We're going to take a look at the plot of speed versus time. That's what part E says. And we describe how this graph differs from earlier trials where the velocity was increasing. How does the slope change and why? And then record your observations in table D of the student guide, which is the last data table. So let's take a look at the graph. You see, when the fan was on, the velocity was increasing, but then once we turned the fan off, then the velocity remained constant. Remember, we had the friction off. Now, if we take a look at this, it's curved for the first 4 seconds, but then it becomes straight after that on the position time graph. Step 5 in part E, the last part, it says once the cart crosses the finish line, observe the plot of the speed versus time graph. So that's what we saw there. Describe how this graph differs from earlier trials where the velocity was increasing. How does the slope change and why? Record your observations in the table D. So the slope is positive and constant when the cart is accelerating on the graph, and it's the velocity versus time graph. It is horizontal when it is going a constant speed. So if we were to go back up to the hypothesis portion, it says if the fan speed increases and the acceleration of the cart increases because a greater fan speed supplies more energy to the cart. And if you were to take a look at the actual data in the data table for acceleration down at the bottom, it would support that. If you take a look at the higher fan speeds, they're higher numbers. So there you go. This is the student guide for this lab. You're going to turn this into Google Classroom. Make sure that all the data tables are filled in. If you don't have access to open up this Word file, I'm going to have an alternative, which is a Google document on Google Classroom. You should be able to find it under the assignments on the Science Google Classroom. You're going to put your submission there. Some more directions are right there. So the purpose of this video is to show you pretty much how to process labs in an Edgenuity Science course. Labs are good hands-on activities to help you understand the content a little bit more. I hope that this was helpful for you. If you have any questions, let me know.